All right, so section 10.3, angle conversions and missing angles. Okay, so like I said, the missing angles is solving for the missing angle in a triangle. We're still going to use those ratios that we did yesterday, the SOHCAHTOA, right? Sine of theta is equal to opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Make sure you guys memorize those things, okay? I tell my youngest daughter this all the time. Like today she's taking a quiz on what they call sequences and series, and I'm like, do you know the formulas for the sums and for your explicit formulas and stuff like that? She's like, kind of. And I just tell her straight out, if you don't know them, you're going to fail. I'm like, I'm telling you, like, I do this for a living. The kids who know this, they do fine. The kids who don't know it, they don't do very well. I'm like, because if you don't have the formula, how can you do the work, right? Here, it's not as intense, but still, SOHCAHTOA, right? Know that. Understand what it represents so that you can do your work, okay? So, angle conversion. So here we go. So this is, I would say, like the easier part of the lesson. Okay, so conversions. All right, so there's two ways that you may have to convert an angle, okay? You may have to go from degree to radians. Okay, so this is one method, degrees to radians. In other words, you have 35 degrees and you want to know how do you change that to radians, okay, radian measure. So we'll talk a little bit more about what a radian means, but we're not going to do that today. But I just need you guys to know the process because of the fact that it is going to come out, like I said, on those state tests. So it's kind of nice for you guys to know it. We'll talk more detail in radians a little later. But degrees to radians is basically given like this. You're going to take your degree value, whatever they give you, and you're going to multiply it times pi over 180 degrees. And that's going to equal to your radian measure. Okay? So you're going to take your degree. If I give you 30 degrees, you're going to multiply it times pi over 180. So 30 times pi over 180. And then you're going to leave it the way it looks with pi. I'm going to put right here, leave the pi. In other words, don't multiply by 3.1415926, right? Just leave pi. So if your answer might be 2 pi or half pi, 3 pi over 2, okay? So leave your answer in terms of pi, okay? So degrees to radians, you're going to do, get your degree, multiply it times pi over 180, and that's going to give you your radian. So what I'm going to do really quick is I'm going to do two small little examples, and then we'll move on, okay? So example number 1 here. All right, so let's just kind of put a number 1 here. I want to change the following degree to radians. So let's do a 200 degrees. I want to change that to radians. And then later we'll do radians to degrees. So 200 degrees times, now to change it to radians, I need to multiply by pi over 180. So pi over 180 degrees. Now you can do this on your calculator, just type in 200 over 180 and it'll do it for you. But if we do it by hand, I can reduce by 10. Let's do that first. That's a nice, I noticed they both end in 0. So let's divide both by 10. That gives me 20 pi over 18. And then that number I can divide by, what, 2? Right? So I can reduce 20 and 18 by 2. So that's going to give me 10 pi over 9. And that's it. That's my answer. Because there's nothing more I can reduce that by. And I want you to leave the answers in terms of pi. So this is how many radians it is. Okay? So the radians is that other little thing that I told you guys. When you see a little r on your calculator, that's a radian measure. Notice this one doesn't have any degree symbol. Okay? So I had a student in second period ask me when we went over this yesterday, do I have to write my degree symbol on my numbers? Excuse me. So do I have to write them on my numbers? And I said, yes. And they're like, but why? It doesn't matter. And I said, no, it does. Radians don't have them. So if you write 30 degrees or just the number 30, and you put an angle, like sine, cosine, tangent next to it, one of them to me is 30 degrees. The other one is 30 radians. Because when you're dealing with angles, a degree symbol means it's a degree. No degree symbol means it's a radian. Okay? So it is important that you guys put the degrees whenever you're talking about degree measures. Okay? If you don't, then I'm going to assume you're talking radians. All right? So let's do one more of these. Just a real quick conversion, and then we'll move on. We'll do a easier angle here. So 30 degrees. So I want to change 30 degrees into radians. So I'm going to do 30 degrees times pi over 180 degrees. Again, I noticed they both end in 0, so I'm just going to divide them by 10, right? So that would be 3 pi over 18. And I know 3 and 18, I can divide both of those by 3, so that gives me pi over 6. And this is pi over 6 radians. So it's pretty easy, right? Just conversion. All you're doing is multiplying and reducing. It's nothing intense. Okay? Any questions on that one? So your formula, if I can highlight it, I guess, is going to be this thing right here. Okay, you're going to multiply by pi over 180. Okay, to change it to degrees, to radians, you're going to multiply your degree times pi over 180. That's going to give you your radians. All right. So let's go to radians to degrees now. This is the second one. So in case they give you something in terms of a radians, and they say, what is it in terms of degrees? Oops, sorry about that. And it did it again. So you're going to get your radian, measure whatever it happens to be, and you're going to multiply it by 180 degrees over pi. So notice all we're doing is flipping it, right? To go from degrees to radians, we multiply by pi over 180. To go from radians to degrees, we multiply by 180 over pi. So it's not like a crazy different equation. It's pretty much the same thing. You're just flipping it over. That's going to give you your degree measure. Okay? So your formula, kind of like we did earlier, is this right here. Okay, that's what's going to give you your degree value. Excuse me. So let's do a couple of examples on this. Again, they're not difficult to do. You just got to multiply stuff out. So first one, let's try a pi over 3. We'll go with something on the easier side. Oops. Just pi over 3. There's pi over 3 radians. Sometimes they write the word radian, sometimes they don't. I gotta get my water right now because there's a frog in my throat, as they say. So I'm going to multiply by 180 degrees over pi. Now the nice thing about this is the pi's are just going to cancel. Okay? The pi's will just cancel. So all you have is 180 degrees divided by 3. And 180 degrees divided by 3, that's 60. So it's 60 degrees. We'll try something a little bit more interesting. We'll try like 11 pi over 6. That should come out to 330. But let's try that. 11 pi over 6 radians. So I'm going to get the 11 pi over 6 and multiply that by 180 degrees over pi. Now remember, the nice thing about this is that the pi's cancel. Okay? So this is going to cancel with that. So I just got to multiply 11 over 6 times 180 degrees. Now, I know that 180 divided by 6 is 30. So that's 11 times 30 degrees. And 30 times 11 is 330. So there's my answer for that. Again, you can use your calculator if you want. It's not a big deal. But that's your conversion. Okay, so this is what you guys are going to be doing in terms of conversion. From degrees to radians or radians to degrees. Just follow the little formula. It's not that difficult. Use your calculator and you should be good. Okay, that's the easy part of today's lesson. There's 8 problems like that. So there's 4 of degrees to radians, 4 of radians to degrees. The rest of it, numbers 9 through 18, are all the missing angle problems. Okay? And it's not like these are insanely difficult, but it's just they're a little tougher because you got to remember your definitions. So let me just introduce you to a function on your calculators. Okay? The sine inverse, cosine inverse, and tangent inverse function. Now, you're going to find those on your calculator above the sine, cosine, and tangent button. So look for the sine, cosine, and tangent button. Okay? And look above it. You're probably going to see in either yellow or blue. Let me check. Let me check one of these here. So yeah, it's going to be in yellow if you have one of the black calculators. It's going to be in yellow. But it says like sine to the -1, right? But it doesn't really mean -1. This means sine inverse. That -1 means the inverse of that function. So that's the function we're going to use to solve for angles. Okay, so these functions are used to solve for theta. Remember, we use theta in math. Usually it's for angles. Okay, it's a Greek letter that we tend to assign for angles. We don't like to use like sine of x, cosine of x most of the time. We like to use thetas. Now, we do use other Greek letters, alpha, beta, gamma, delta, etc. If we need them. We sometimes do use x, y, and z if we need them, but we try to stick with theta if possible. Okay. Sometimes we use like capital letters, sine of capital A, sine of capital B. So we'll see how the homework makes you do it. But that's what we use. Now, I'm going to show you how to go through it in the following problems, okay? So here we go. For this, we're going to find the measure of the angle, okay, round to the nearest degree. So round to the nearest degree. So here's my instruction for the next couple of problems. So you do have, what did I say, 18 problems? So you're going to do 10 problems. So we'll do maybe like 3 or 4 of them for you guys. So here we go. So example number 1 for this one. So find the measure of the angle round to the nearest degree. So the first one looks like this. We're going to draw that out. Now your job is to figure out which trig function am I going to use. Am I going to use sine, cosine, or tangent? Okay, so the best way to figure this out is to start labeling your hypotenuse, then your opposite side, then your adjacent side, and then from there you say, oh, I know the following, it has to be this, right? So, where is my hypotenuse? Is it 2, 4, or side AB? Side AB, right? And if you're wondering, well, I don't know which one the longest side is, well, you can look sometimes, but more importantly, it's the side opposite the 90-degree angle, right? So this would be your hypotenuse right here. So notice, since I don't know the hypotenuse, then I know I can't use sine or cosine because those involve hypotenuse, right? That means this probably has to be a tangent function, but let's kind of keep going here. Which side is my opposite to angle theta? 2, right? 2 is the opposite. So this has to be adjacent. Remember, how do I know that 2 is my opposite? It's the side that is not interacting with the angle, right? The angle has this side here and this side there touching it, right? Opposite does not touch the angle. So that's why it's 2. So I have opposite and adjacent. So according to definitions that we learned yesterday, I get to use tangent of theta because that has opposite over adjacent as its definition. 2 over 4. Okay, that's a half, right? So tangent of theta is equal to half. All right, so let's find the angle. So this is what you're going to do. To solve for the angle theta, I want theta to be by itself. I'm going to take the tangent, I'm going to throw it to the other side. When you do that, it looks like this. It becomes its inverse when you throw it over. And now you're going to grab your calculator and you're going to do tangent inverse, so shift tangent, and then put half. I'm just going to put 0.5 because it's the same thing. And I get 26.5. So the approximation is 26.565, etc. But they want me to round it to the nearest degree. So that's 27 degrees. And that's my answer. Any questions on this one? I said these problems aren't like insanely difficult. Like I said, they look like they could be because all of a sudden we got these triangles that we got to solve for. But they're not terribly difficult because it takes a couple steps and you use the calculator to solve it. You just got to make sure you use the right function. Okay? So I'm going to make sure I at least do one of each. So that was a tangent. Here's another one. .2, a 3 here, theta's there. So remember, we're trying to solve for the angle of theta. But we're going to label our triangle so that we know exactly which function to use. Where is my hypotenuse? 6.2, okay, because that's opposite of the 90, okay? So that's my hypotenuse. Now, according to the angle theta, which one is my opposite? 3. That means that this has to be adjacent. Which trig function am I going to use? Cosine is adjacent over hypotenuse. Do I have adjacent? No, I don't, right? So I'm going to use sine, right? Sine is opposite over hypotenuse. That's exactly what I have, right? So again, it's not that this is hard. You just got to look and say which one matches, right? So cosine of theta is equal to opposite over adjacent. Now that one I'm not going to be able to reduce easily. If it was 3 over 6, sure. If it was 3 over 6.3, sure, but not 6.2. So I'm going to solve for theta. So I'm just going to write theta equals cosine inverse of 3 over 6.2. And at this point, you're going to use your calculator again, right? So cosine inverse of 3 divided by 6.2, rounded to the nearest degree. Can someone tell me what it is? Oh, sorry about that. Thank you for that. I was remembering what you told me and I did not get it out of my mind. Sorry about that. Thank you for that correction. I heard both of you guys tell me it should be sine. Sine inverse 3 divided by 6.2. All right, someone give me the answer. What is the nearest degree? 29 degrees. It comes out to 28.938, right? So I'll put it right here. 28.938, etc. So nearest degree would be 29 degrees. So you can see the hardest thing is making sure you write down the right trig function, right? But other than that, it's the calculator is doing most of the heavy lifting for you guys. So just write it out properly. Let the calculator calculate. So we're going to do one more. We did a sine. We did a tangent. Let me look for a cosine. I'm looking to see if we can find one that's going to be cosine here. All right. So this one should be that. That way at least you see all three functions being used. And then I'll let you guys do the work. Here's ABC, triangle ABC. Here's your theta, 15 and 12. So there's my triangle. So which one is my hypotenuse? The 15, all right. Where's my opposite? Side BC or CB, okay? Depending on how OCD you are, you might say BC, right? I always tend to write it in alphabetical order just out of habit. Usually mathematics prefers alphabetical order, but it doesn't have to be. And then that leaves 12 to be my adjacent side, okay? So I have an adjacent and I have a hypotenuse. So this is going to be cosine, right? So cosine of theta is equal to 12 over 15. Now, do you have to reduce it in order to do the problem? No, you don't. But it's just a stickler in me always says, like, you should reduce everything before you do any work. So I'm just going to reduce it. You don't have to if you don't want to. You can still find the answer. It'll be just fine. So if you reduce by 3, this is going to give you 4/5. Now solve for theta by sending the cosine over. So cosine inverse of 4/5. That's going to be approximately 36.869, etc. So to the nearest degree, you're going to put 37 degrees. Okay, and that's what your homework is like today, guys. It's conversions in the beginning and then finding missing angles. All right?